150 kilometers. That is the exact depth at which a sovereign nation's critical logistics and command hubs can now be instantly vaporized, not by a massive strategic cruise missile, but by a rapid-firing tactical rocket. In May 2026, Europe effectively declared its military independence from the United States. Deep within the isolated missile testing grounds of Levant Island, the French Directorate General of Armaments, alongside industrial titans Thales and Ariane Group, successfully conducted the first live fireflight tests of the Thales XFire long-range multiple-launch rocket system, sending a guided FLPT 150 tactical ballistic missile screaming into a precise grid zone. The strategic stakes could not be higher. For decades, Western Europe has cowered under the shadow of heavy anti-access area denial umbrellas, relying entirely on American-controlled munitions restricted by rigid export laws. By launching a 100% ITAR-free strike platform capable of blinding electronic warfare systems, France has shattered the status quo, effectively realigning the balance of power across the European continent. This single event has sent shockwaves through regional command centers, forcing immediate military reassessments from Paris to Moscow. With this breakthrough, Europe enters a high-stakes era of multi-domain warfare, where the reliance on foreign supply chains is rapidly burning away. Is this the definitive turning point for European strategic autonomy, or has Paris just ignited a highly volatile defense race that it cannot financially sustain? Before we go on, did this defense breakthrough surprise you? And what do you think it means for the future? Subscribe now so you never miss an update, and tell me where you are watching from. To truly understand why this breakthrough is causing an uproar, we must dissect the engineering marvel hidden beneath the heavy armor. At the heart of this revolution sits the Thales XFire mobile launcher, a system meticulously designed by Saframe on a heavy 8x8 tactical chassis. This platform completely discards the rigid, vulnerable posture of older artillery, morphing into a highly survivable, rapidly shifting weapon. When rolling down a European highway, the launcher seamlessly blends in, closely mimicking a standard logistical cargo truck to effectively deceive enemy orbital reconnaissance. However, the true devastating power lies within the FLPT 150 guided tactical missile, developed by Ariane Group. This munition directly inherits high-density solid propellant rocket motor technology from the M51 submarine-launched nuclear ballistic missile, giving it unparalleled acceleration and a high-altitude trajectory that plunges down at hypersonic speeds to breach short-range air defense nets. More importantly, Thales has eliminated the Achilles heel of modern precision weapons by integrating the Topstar Smart Global Navigation Satellite System receiver and the ultra-precise top-axis inertial measurement unit. This combination creates a completely jam-resistant brain, meaning that even if an adversary activates heavy electronic warfare assets like the Krasocka 4 to completely blank out satellite signals, the FLPT 150 maintains its course, striking within a 10-meter circle purely through independent mathematical calculation. For France, this massive financial investment solves an existential operational crisis. The aging French LRU platforms, which are heavily modified M270 systems, are rapidly approaching the absolute end of their service lives, while their American-supplied ammunition stockpiles have dwindled significantly. By mastering a homegrown, completely ITAR-free deep precision fire network, Paris ensures that its army can dominate a high-intensity war of attrition without needing permission from Washington. Can this precision engineering truly offset the sheer mass of opposing rocket artillery, or will tech-heavy solutions fail when facing a prolonged industrial conflict of numbers? This technological leap does not merely upgrade the French arsenal, it profoundly disrupts the entire geopolitical architecture of Europe. By successfully demonstrating an independent long-range rocket capability, France has effectively broken the American monopoly on deep precision strike weapons. For the past several years, Washington has used the highly sought-after M142 HIMARS platform as both a military shield and a diplomatic lever across the continent. Now, European nations looking to bolster their forces have a viable, domestic alternative that comes without foreign political strings attached. This shifting dynamic has triggered immediate, sharp reactions across the region. In Moscow, defense officials view the development with severe concern, as a highly jam-resistant rocket system operating from NATO territory fundamentally threatens their command centers and challenges the supremacy of their S-400 air defense networks. Meanwhile, nations along the Baltic and Eastern European frontiers are watching Paris with intense interest. As France signs far-reaching security pacts, such as the recent Narvik agreement with Norway, these frontline states see the new platform as a vital conventional deterrent to reinforce the continental defense grid. Even the United States faces a complex dilemma. While Washington officially welcomes stronger European defense spending to share the collective security burden, American defense contractors are quietly alarmed by the sudden emergence of a potent, homegrown competitor in a multi-billion-dollar export market. By fielding this tactical ballistic capability, France is forcefully carving out a new sphere of military influence, asserting that Europe can and must secure its own borders. Will the arrival of this European long-range system successfully deter regional adversaries and stabilize the continent? Or will it instead accelerate a dangerous procurement race that deepens the divide between major global powers? While the technical validation of this new European weapons system marks a historic achievement, the ultimate test of its strategic viability lies ahead. The successful flight trial proves that the engineering works, but converting an advanced prototype into a sustainable warfighting capability introduces a massive industrial bottleneck. In an era dominated by high-intensity wars of attrition, a weapons system is only as effective as the supply chain supporting it. Moving forward, the Defense Consortium faces a major production challenge, as manufacturing high-density solid propellant rocket motors and advanced inertial navigation units requires an uninterrupted flow of highly specialized raw materials and chemical components. If global supply chains fracture, or if economic pressures slow down factory output, the new launcher risks becoming a highly sophisticated but critically scarce asset on a rapidly moving battlefield. Furthermore, the true measure of military deterrence is found in the fluid dance between offense and defense. True military sovereignty cannot be achieved through a single technical breakthrough. It requires continuous adaptation within a contested multi-domain environment. The introduction of this highly accurate rocket system will inevitably force opposing military powers to rapidly evolve their own anti-access area denial strategies. Adversaries will not sit idly by. They will actively develop countermeasures, from refining hyper-localized electronic warfare tactics to deploying advanced mobile air defense systems specifically calibrated to intercept high-altitude, fast-falling ballistic targets. Ultimately, this milestone serves as a stark reminder that true strategic autonomy is not a final destination, but an ongoing, high-stakes race of technology and industrial endurance. As the balance of power shifts, the question remains whether this domestic alternative can scale up fast enough to secure continental frontiers. How will opposing defense networks reshape their doctrines to neutralize this emerging strike threat? And what is your take on the future of self-reliant defense? Please leave your analytical thoughts in the comments section below.